Hello, everybody. Welcome to today's webinar, Mathcad 4.0 in Action. Join us for a dynamic view of Mathcad's capabilities. Make XY polar contour plots, connect with Excel and Creo, fully understand Mathcad's value, and reduce errors. And let me tell you a little bit about today's presenter, Colleen Garrigan. Works at the Virtual Center for Excellence at PTC. And even though she works in software, Colleen has a degree in chemical engineering with a focus on biomedical engineering. Wow, that's sure a fun fact, or an interesting fact to say the least. Welcome, Colleen. And I want to tell you also a little bit about Novedge. Oh, sorry, this is the wrong slide. But anyway, Novedge is one of the largest online stores for design software. And we offer a huge assortment of software solutions that cater to virtually every designer's needs. So visit novedge.com, follow us on Facebook, Google+, and now even on Instagram. And on our next webinar, THEA for Cinema 4D, version 2.0. And I want to remind everybody that this webinar will be recorded. So if you want to rewatch it, you can do so on Vimeo and YouTube. And now, without further ado, I'm going to switch to Colleen's screen. And in a few seconds, that will appear. Take it away, Colleen. And welcome to the webinar.
All right, so yeah, welcome everybody. Thanks for joining. Again, my name is Colleen and I work in Pittsburgh, Pennsylvania. So a little bit about Mathcad to start. So what we're going to do is we're going to walk through some PowerPoint slides. Then I'm going to move us into a demo about Mathcad, and then we'll have a few more slides, and then we're going to end with a sneak peek into Mathcad Prime 5.0. So Mathcad is all about the engineering process. It's a tool that you can use to help you document the whole engineering process, including all those calculations and any visual aids you want to document with you. So a lot of the challenges that we find companies have include that there's a lack of standardization for how to document your engineering process. So you have a lot of calculations and intellectual property that describe how your products work, but there's a variety of ways to document them. You could have it on spreadsheets, you could have computer programs for it, Excel documents, pencil and paper, or manuals, or a plain handwritten engineering notebook. So there's not a really good one way to go ahead and have your whole engineering process documented. And then once you have it documented, it's hard to share and reuse that intellectual property that you made. That could be because of it's scattered between all the different resources, or because it's lost from projects to projects. You could have someone retire and you lose all their handwritten notes or turnover. And then errors are very hard to catch with the traditional ways. You know, on the Excel sheet, you have to search through cells and cells to find that one little error that's maybe just with a unit. So a perfect example of that is in 1999 when NASA sent up a Mars robot. So what happened was that it made it all the way to Mars to crash into the atmosphere and burned up. So it lost millions of dollars because they used a vendor who used a different units for force. So the computer calculating how to move the robot with using different units than the robot computer. So they didn't communicate well and the robot crashed into the atmosphere and burned up. If they had used Mathcad with units involved, Mathcad would have told them or converted it itself into compatible units. So Mathcad can fix all of these issues. And again, that's the tool, the solution to analyze, solve, document, and share your engineering design processes. Okay, so what is Mathcad? So again, it's that digital engineering notebook to perform calculations and document your design intent. So it's basically a software made for documenting the process. However, it's more than just a document. It's an engineering notebook. So that means you can include drawings, you can include Excel spreadsheets, you can perform calculations right in its strong math engine, you can create plots, and you don't have to do it with coding. So you're not doing any coding to make this engineering design notebook. You're doing it all with just typing out, you know, X plus Y equals, you know, you're doing it with imports for Excel sheets and drawings, you know, no coding involved. So it looks like a document, except it's much better than handwritten or typed out notes. So a little bit more about Mathcad's capabilities include that it's a whiteboard interface that you can add a grid onto it or not. You can leave it more like, just printer paper. And it again has that natural math notation with just the x plus y equals. So you're not having to learn a whole new language to use Mathcad. And it's all going to put up in a nice and easy readable form. It's going to keep track of everything for you. So it's going to know what units you were using above and make sure that you're not using anything that's incompatible, or go ahead and convert those units for you so that there's no simple mistakes in there. So it's going to document your live math, your text, graphics, and programs all into one page. So it's going to convert those units for you again. It won't allow you to have those simple, easy errors. And so your graph, your scrap paper that you start off maybe trying to figure out a formula or trying to figure out a solution can end up becoming your final paper that you're going to go ahead and publish and share with everybody, because there's not any extra step you have to take there because it's already in a format that is ready to share. So some more about its capabilities include it's a WYSIWYG document, which means what you see is what you get. So you don't have to format it different for printing either. So you can just print it out and it's ready to go. Mathcad has a lot of pre-built functions in with it. So there's a huge library of math notations, solving, data analytics, and statistics. So that means you're not redefining or teaching the system how to do a function. It's already built in there. It can also help you build XY plots, polar plots, contour, or 3D plots. And those plots are all live. So you can stretch it out, change the units. It's going to change with, if you go up and edit a formula, it's going to edit with you. It's not set in stone. It's not just a picture of a graph. It's a live graph. And there are also a lot of different ways to display your data in Mathcad. Mathcad is also fully integrated with Creo Parametric, which is PTC's CAD tool. So it's going to document your design intent if you have it connected with your CAD. So instead of just having your end product with your CAD, you can have the Mathcad attached to it, which will describe all of the decisions that went behind making your final product. It's going to communicate easy to anyone who you're sending it to because it's analysis-driven design. So you can take your variables, parameters, and calculations and analysis from Creo and put it into Mathcad. So it has words attached to it. Someone can read and understand what you're trying to do. But not only can you bring things from Creo into Mathcad, but you can send them from Mathcad back into Creo. That means that you can verify that your design choices are correct. You can bring in whatever parameters you make in Creo, bring them into Mathcad, do a couple calculations with them, and make sure they fit your design requirements. And then that way you'll immediately know if a change needs to be made. So talking to each other really extends the usefulness of both. And again, you're doing that, you're checking while you're designing. You're not fully designing and then checking. And then you can also verify and validate that your design is going to work like you want it to. Okay, so now I'm going to move us into a quick demonstration here, and then, but don't worry, we'll come back to PowerPoint slides in a minute. Okay, so we're starting off with a kind of already made a Mathcad sheet for us here to look at. And as you see, again, it's that whiteboard interface. It looks very simple, almost like a Word doc. And we do have that grid for us in the background there. But you can format the text any way you want. So we have the title page pulled up here. So it's very similar again to that Word doc. It has that familiar ribbon up at the top where we can change the text around, and the user interface is very simple and familiar. So it's like a document, but for engineers. Again, you can turn off and on this grid whatever way you like the best, or your company standards. So if we move on down to the next page where we get down a little bit into the math and the nitty-gritty, you can start with a picture. So again, I talked about how you can import images. We'll also import Excel here in a minute, but it's very simple to go ahead and import any pictures you want. So if you already have some made pictures, or even if you want to input the end product from Creo, a picture of that, You can easily import any pictures that you have right into Mathcad. So that means you're not just doing all the calculations x plus y equals, but you're documenting the process. You're documenting that this picture is important to whatever you're trying to do. So if we go ahead and make a few variables here, all we're doing is typing B and D equals, no coding or anything like that. Very simple, easy way to go ahead and type things out. And then we can go ahead and use those variables that we just made up above as well. So there's, again, no coding, nothing extra that you have to do. We made those variables and then you can easily add them into formulas there. So we see here that I made a small typo here. I said H instead of D, so we'll see how Mathcad acts with that. So we see here, oh no, that's not at all what I was looking for. I didn't have any units on the variables I made. So we can go ahead and ask Mathcad, what variable did I actually use here? And you can ask, okay, what is H? And it'll tell you there, oh, that's a preset variable, which is Planck's constant in this case. So you can say, oh, that's not what I meant to do. Let's go ahead and change it back to D there. And it'll automatically update anywhere you used D or H after that. So let's take a quick look at how it interacts with units as well. As you can see, as we put in units into the variable, it's going to automatically update lower for us about what the units end up being. And all we have to do to change, so the default units there was meters. So all we did was change that meter into a centimeter and it updated the value for me. So it's not just an input, it's actually redoing any calculations it made with anything you input. So it's going to keep track of those units for you so you can't make a mistake. It'd be very hard to make a mistake. And what we're showing here is that it won't do calculations with incompatible units. So you can't accidentally add centimeters and seconds. Mathcad will stop you. So that was a little bit about how easy it is to go ahead and make new variables, to make a formula with them, and then how Mathcad keeps track of formulas. So we're going to look at a little bit about how you can input and use your Excel sheets that you've already made. So you probably already have Excel sheets, tons and tons of Excel sheets that you don't just want to throw out. You want to be able to reuse them. And that's very easy to do in Mathcad. So you can just find it already saved on your computer, and you're going to tell Mathcad what rows and columns you want, and then you can just insert them here. So it's actually reading from the Excel sheet live. You're not just bringing in numbers. It's reading live from that Excel sheet. And you can make it into a variable here, or a matrix in this case, with the different metals and values that we bring in. So again, you're not having to throw away that Excel you already made. And like I was talking about before, it's live, so you can change the columns and rows that you actually want to bring in, and it'll update for you. So it's not copy pasting, it's reading the Excel sheet live for you. And then you can actually do calculations out with the Excel you bring in as well. So this is just some matrix notation here that we're going to bring in one value from this matrix we pulled in from Excel. So there we go, it does the calculation out for me. All I did was bring it in from Excel and then reuse that data I already had. So you don't have to do any programming. It was just like how you typed it out on a piece of paper, and you don't have to go in and re-find all those values again. It's reading it live for you. Okay, so we're going to do a little bit more math here. So again, we have that nice big picture so you can visualize whatever I'm doing right in that Mathcad notebook here. So what I'm doing is I'm doing some beam dimensions for later on when we do some more calculations. So I'm going to define my variables and type in the units, so you can mix and match the units. Type in centimeters and meters, and it'll make sure, or even inches in centimeters, it'll make sure to convert it into its default unit unless you go ahead and change your default unit. Okay. So we're going to go ahead down and actually do out some calculations with those variables that we made up above. So we're going to find our deflection. So if we calculate it again, we just set those units variables a couple seconds ago. So we're going to reuse them here and calculate out this big formula for deflection down here below. And we see again that Mathcad's default is meters, but to go ahead and change that, just retype in whatever acronym for the units you want, and it'll update for you. A nice feature also about Mathcad is that you can hide regions. So sometimes you do math behind the scenes and maybe a derivation, and you don't really want that to be on the final sheet. You don't want people to have to think about it and re-go through it. So what you can do is you can make a region that you know you're going to want to hide later. So you can have all this good, juicy math in the background without having someone have to dig through it themselves. So you can go ahead and hide that back, so you won't no one else who you send it to will have to see it, unless of course they want to, and then they can expand that region and go through it too. Okay, so we'll move on to a little bit more about the plotting capabilities in Mathcad. So you can make 2D plots, charts, and graphs. You can change the color and background of your plots, so to make it, you know, company standard or whatever way that you want it to look like to convey your plot, your graph with clarity and make sure it gets the message across. So we're going to go ahead and change the, you know, the line details a bit here, make it thicker, change the color. And again, this is live, it's not a picture, so you can add in vertical markers. You can move it back and forth to really highlight any particular value you want it to point out. So these live plots are really going to help you document and calculate and show what you're doing to document the process. So here Mathcad does a little bit more challenging math here, a little bit of programming. So what it does is it's calculating out the deflection change as the load position varies, and then you can make a nice contour plot with that. So if we go ahead and do a 3D plot also with that calculation we saw above, we'll define our variables here, our 3 variables, one for each axis, and it's easy to toggle between the 3 of them with our axes up there in the upper right corner. So we can tell it the range we want each variable, each range to be. And once we do that, we can go ahead and edit the actual plot as well. So we'll go ahead and fill our plot up here, give it some color. And again, this is a live plot, so it's not just a picture of something. You can move it around, rotate it, zoom in and out, you know, look at one particular section way up close. So all of this is all within your documentation, all with where you're saying what you're doing, you're calculating things out so someone can easily follow back and forth whatever you're trying to do. All right, we're going to go ahead and show a little bit with how it communicates well with Creo, which is again PTC's CAD solution. So what it does is it's making all your engineering calculations in one place. So traditionally, you might have documents or Excel sheets that are describing design intent and design history. In old CAD models, you could have it in Excel, email, Word docs. It could be scattered over many different softwares. And so that important information is disconnected from your actual CAD model, and it could get lost over time. But Mathcad can be fully integrated with Creo Parametric. So it's an engineering notebook embedded in your CAD model where you can keep your design intent and history of decisions connected to your CAD. So they won't get lost over time, and you won't have to redo calculations or design intent that you already had documented. So it's not only connected, but it can communicate back and forth. So you can send parameters, dimensions that you set from your CAD into your Mathcad workbook here. So we're going to go ahead and create that relationship right now. So you can edit that Mathcad workbook directly in your Creo model here. So we're going to go ahead and make an input here so you can quickly and easily input parameters from the Creo CAD model into the Mathcad worksheet. So we're going to input into Mathcad the diameter of the piston head and the crankshaft radius. So they're going to be shared between the actual CAD model and the Mathcad worksheet. And what it's going to do when we do that is it's going to let us know that Mathcad is outdated, that we need to update Mathcad so it can show the correct dimensions from the actual CAD model. So it's going to make sure everything is up to date and it's not going to let you use old values. So in this section here, we look at how you can use Mathcad to verify, to make sure the decisions you're making are correct ones. You know, they're actually working for the design you're trying to make. So you can use whatever design requirements, formulas you need to make sure everything is fitting what you need. So in this particular example, the allowable range for the compression ratio in the engine displacement here can be verified. And so you can validate while you're doing them. And then we can also output from Mathcad into Creo. So we're going to output the depth of the piston head spherical cap and then the diameter of the spherical cap. So when we go ahead and push those back into Creo, Creo is going to do the same thing and let us know that it's outdated. So they're not just connected, but they're communicating. You can push inputs and output back and forth between each other, and it'll update here for us. It'll regenerate in the CAD side. So again, Mathcad enables PTC Creo users to create and maintain a digital engineering notebook, ensuring that there's a single source for design intent that's fully connected to the CAD model. So it provides you the capability to do analysis-driven design. You're going to check to make sure the decisions you're making are correct while you're making them. And it supports those verifications and validation efforts. So having Mathcad will ensure that the design intent of the engineering team is protected and is accessible to future efforts. So you won't lose a whole bunch of design process that you went through and have to start again from the beginning. And that'll really reduce the rework and save you time and money. So I'm going to move us back into the PowerPoint here, and we're going to review some of the new capabilities that Mathcad 4.0 had for us. And then again, we'll give you the sneak peek of Mathcad Prime 5.0. So taking a quick look about what's new in 4.0 for us. So it's going to make it easier to show, solve, and secure your engineering designs, your engineering notebook. So you have things like performance enhancements, where your document and plot capabilities have been improved. You have the content protection. So the same way that we built a region that we can hide later on, you can do that the same way, except you can lock it so other people can't make changes to it. And you're going to be able to reuse your Mathcad more, because you're going to be able to paste it into Microsoft Office, Microsoft Word places. So you won't just be able to print out and send your Mathcad notebook, but you can actually copy paste whole regions and bring them into Microsoft Word. Mathcad can also be it's in the order that makes sense for whatever design process you're going to. You can switch back and forth between draft mode, so it allows you more visibility without the distraction of headers and footers. Showing your engineering process has also gotten better because you can plot even more data points on an XY graph than previously. We talked a little bit before about how you can make regions, so with Mathcad 4.0, you can lock those regions. So you can protect areas from edits, but still have them viewable. You can make that password optional, so if you only want people with the password to view it, you can do that. And then you can also lock regions to protect your intellectual property. Mathcad is now its own OLE container, which means you can embed drawings right into it. So again, that's going to be like that live thing, like Excel, where you can change the rows and columns it's reading from. You can open up your document editor straight from Mathcad. you also have further capabilities to work with third-party applications. So you can copy and paste regions from Mathcad straight into Microsoft Word and keep all the source formatting, so you won't lose any of the formatting you did in Mathcad when you copy and paste it. Okay, so now I'm going to move us into the quick demonstration, the quick sneak peek of Mathcad 5.0, which isn't released yet, but you guys can still see a sneak peek for it. So like before with Mathcad 5.0, you can still solve, analyze, and share your most important, your most vital engineering capabilities. But now Mathcad 5.0 has significantly improved the 2D plotting capabilities. So it's the same before where you can make informative and clear plots right in your worksheet, but now the format is completely customizable and you can have multiple y-axes on the same plot. So that makes it very easy to compare your different datas with ease. So let's go ahead and make a few different formulas here for my y-axes, and then we'll see how they populate immediately in the graph here when I type them in. So we're going to create with the same ease before with the 2D plots, but we're going to do it with multiple y-axes. So this can make sure that your data is represented quickly, which can decrease your time to go ahead and send out your documentations. And we can edit any aspect of the plot here. So it pops up a window here and you see we have a lot of different options to go ahead and select on that we can customize to make it for even our own company standards or our own personal choices about how we want everything to be viewed. So let's go ahead and start with editing the title here a bit. So we can add in a chart title and then edit the appearance of the plot title. So you can call attention and showcase the title. And then again, you have a whole bunch of text options, you have color options, you know, how big it is. So you have all of those capabilities that you would in Excel or Word, but now they're also in Mathcad. So we're going to go ahead and add grid lines on here. So it's easier to view what our graph is actually trying to tell us. And then we can easily add on different axes titles here. So you can simply communicate your complex engineering data without any ambiguity about what these axes represent. It's easy to go ahead and italicize it. So again, the same capabilities that you have in any other graphing tool you have are now available in Mathcad. And then we can go ahead and add on a legend here quick. Make sure that, again, there's no confusion about what you're trying to represent. So you can further simplify and clarify your communicating your engineering data here with adding in this legend here. So Mathcad Prime 5.0 remains at the forefront of engineering software world to deliver computational software with ease of use. So you can enhance the visualization of your data with the new and robust 2D plotting capabilities in PTC Mathcad Prime 5.0. So we started off with kind of a bland graph that still was great because it had the 3 different y-axes on it, but we ended up with something that conveys the message much clearer here with this different formatting. So that was our sneak peek into Mathcad 5.0 for us here. So moving on to some of the value that Mathcad in general gives you is that it's going to prevent the loss of your intellectual property because your whole documentation of your engineering process is all in one spot. The text that explains why you did what you did, along with the calculations and any visual aids that you want. And you can also verify and validate that the decisions you're making while designing in Creo, you can make sure that those are the right decisions. And then you're going to make sure that there's no simple mistakes like unit confusion like there was with that NASA robot. You know, you're not going to have those issues because Mathcad is going to tell you, oh, if the units aren't compatible. You're also with this tool where you can quickly type out formulas. You're going to speed up your time to market because instead of having to search through cells that are hard to see fully what's in them, you won't have to do that. You can see big and bold right in front of you what that formula actually is, and everything's going to be in one spot. So people who you need to send up your documentation up through the change can see it all in one spot, and they'll be able to understand quicker what you're trying to convey as well. You also have that document that you can give to any compliance issues. So you can document how you got to your end design, which you can show both internal or external. So thanks so much for stopping by and listening to me go through all of that. I really appreciate it. We have a while left here where I can listen to any questions you have. But again, we went through about how there's normal with the traditional ways of documenting your engineering process, trying to use Excel or emails to go ahead and document not only calculation, but the visualizations. It kind of gets scattered. So with Mathcad, you can combine it all into one, so you have one easy document where you can read through and understand why the designers made the decisions they did. And then we went through and saw what Mathcad actually looks like. It looks like just like a whiteboard that you can easily type, no coding you have to do to get on there. And then Mathcad's going to keep track of your units for you. It's going to allow you to reuse any images you made or any Excel sheets you have. And then we went through and talked about how well it can communicate with Creo back and forth. You can push inputs and outputs from Creo back into Mathcad, and they'll tell you that they're outdated. And then we again saw that sneak peek, Mathcad 5.0, so you know that they're still making new improvements. They're still trying to make Mathcad Prime the best it can be, especially with those 2D graphing capabilities. So again, thanks for listening. I'll be happy to answer any questions. So I'm not sure if we have any questions yet, Barbara,
Not
but
yet, not
thanks
yet,
again for
Colleen.
listening.
I want to thank you for this was a real dynamic presentation. I enjoyed it very much. And thank you for the sneak preview of what's coming in Mathcad 5. That's very exciting. And we're hanging out a few more minutes. If you have any question, this is the time. Colleen is here at your disposal, and we're listening. Ask us anything. That was great, Colleen. Mathcad saves lives, it turns out, right? I had no idea, but
Or at
yeah, it
least
figures.
money.
Yeah, it
Yes.
figures. Yeah, of course. No more mistakes in calculation.
Mm-mm.
All right. Hanging out. Let's see. No, no questions. While we still wait for questions, I'm leaving the tab open. What I'm going to do is to switch to my screen in a second, so I can thank everybody who joined us today and remind them to visit novedge.com, when you can find Mathcad 4 and soon Mathcad 5. And I want to remind you that our next webinar would be on TM Render for Cinema 4D. And also, if you missed part of this presentation, I'm recording it, so you can go on Vimeo and YouTube and watch the presentation in its entirety. Colleen did a spectacular job, and you can watch it over and over again. There are no questions, Colleen, so we're going to bid goodbye to everybody. Thanks again for joining us today, and looking forward to Mathcad 5 at this point. Very exciting, and yeah, well, hopefully you will be able to lead another demo for us again. Fingers crossed.
Absolutely.
Okay, thanks again, everybody, and have a great rest of the day. Bye-bye.